Now members, we are going to see what happens if you are given a CDF. Then they ask you to get the PDF, but this is very easy, we have seen it. What happens is the data you get the expectation and then the value of X. So if this is a PDF, remember, they are telling us that it's simply from distributed. In simple terms, this value here is A, then this one is B. So when they give you this in simple terms and they ask you to rectify the expectation, here you can easily get the expectation because you know that our part A, our expectation of X in a uniform distribution is given by over 2. This works if you are in uniform or rectangular distribution only. So now it's that from here, my interval is 2 less X less or equal to 7. So our interval is always, so this is my A, this is my B. So from here, my expectation is going to be 7 plus 2 over 2, which will be 4.5. It is. When I come down to my variance, my value of X, we said for it it's B minus A squared over 12. So putting them there, is that our B is 7 minus 2 squared the whole over 12. And this one is going to give me 25 divided by 12. So here our value of X is 2 whole numbers, 1 over 12, which is. And so you are done with that. And now getting the probability of this. So our part B, we said if they give you the probability of 3, and you have the CDF, this is as simple as getting f of 5 minus f of 3, which will be, now this one, you see 3 and 5, all of them are in this range. So you're using this CDF now. So you have 5 minus 2 over 5, then minus, this one you have 3 minus 2 over 5. Why? Because our capital F of X is X minus 2 the whole over 5. Then just substituting. So this will give us 3 over 5 minus 1 over 5, which will give you 2 over 5. And you are done with that. Then it is find the PDF of the distribution. PDF is saying in part C, I want us to get a CDF, but we say our CDF at this the small f of X, we differentiate capital F of X. So you see, for it's that our f of X from here, we say it's 0, meaning this one will also be 0. So for X below 0, so that our capital F of X is 0, implying that even our small f of X, we saw it's 0. Then when we come to this interval between and 7, that our capital F of X there is X minus 2 over 5. So meaning our small f of X, we differentiate this capital F of X. We differentiate this, we get 1 over 5. We differentiate all of that. So what about X greater or equal to 7 for this interval? So that our capital F of X there is 1. So our small f of X will be, we differentiate this, which will be a 0. So now when we come and you give this as a PDF, you see we have 0, this is 0, and this is 0. And we said whenever we have our f of X as 0, it means that we put here 0 elsewhere. So the only surviving thing is 1 over 5 for the interval, then 0 elsewhere. This 0 elsewhere is standing in for this one, and it's 0 when X is above 7 and when X is below. When X is below 2, not 0, below 2. So that's how we define it. Now they want us also to, and hence sketch it. So to sketch it, our sketch of f of X is very easy. You see that it's going to be a constant. This is just a constant function. So now you just get your rule. Then you draw it there like that. So this is now your small f of x. So here I have, say, this is the case. I say this is 2, then this is going to be my 7. This is my x. So I assume that this is going to be my 1 over 6. So when x is 2, it's 1 over 6. So which is there. When x is 2, which is there. And then when x is 7, it's still 1 over 6, like that. Then we join these two things there. From that, then to that, like that. So that's how we draw f of x equaling to 1 over 6. I think you see this is corresponding to that 2, and this is corresponding to that 7. So there we have sketched small f of x with this. So that's it, members. I wish you well. Sorry, this is 5, not f. This is 5, this is 5, not. So this is 5.